What's going on, everybody? Eric here from Panola, and today we're going to be covering Objective 2.2 in our continuing coverage of Security Plus and going objective by objective to get the nickel and dime version of what's going on inside of that CompTIA certification. Now, we covered this a lot in our Panola.edu courses, such as ITSY 1400 and ITSY 2400, where we go more in depth over programs like cybersecurity, networking, and even intro to digital forensics. And the reason we're doing this today is we're going through the individual objectives of Security Plus to help out not only the students at Panola, but you on the internet, to make sure that we have a basic understanding of some of the security components going on inside of Security Plus, just to help folks out. And today in Objective 2.2, we're going to be summarizing virtualization and cloud computing components. And this is covered inside of Chapter 10 of our CompTIA Security Plus study guide for SY0601. Now, at this point, I do want to note that 701 is coming out, but the basic topics are still going to be the same, and I will update once all the material comes out for 701. So what is virtualization? Well, that's where we take the regular internet that we know it, the computer systems that we know it, and we make the matrix where we use humans as batteries. Not really, but what we're doing is we're utilizing our physical host systems to create more capabilities for data availability across the actual internet and system networks themselves. And we do this by breaking everything down into different containers and components, and we'll go more into that in a minute. But for instance, this machine right here that we're actually recording on, we can use this machine to open up 5 different operating systems at one time to be able to open up a mini server farm here in this recording studio that I'm in. And why would we do that? Well, sometimes it's easier and cheaper to virtualize than it is to be able to buy all the individual equipment for each individual server that we want to set up. Because it may be cheaper for our organization to buy licensing for one hypervisor suite than it is for those 5 individual servers. Because this system right here was in the ballpark of like 1,500. And we could run a decent server off of that, but we'd have to do 1,500 times 5 if we wanted individual physical servers. But with the ability of implementing a type 1 or type 2 hypervisor, we can take and expand this one $1,500 system, roughly, into 5 or more, depending on the amount of resources that we have, saving a lot of money. And this is where we get into what actually is a hypervisor. And that means that we use the system for isolating those different virtual operating systems from the physical host itself. So the hypervisor is the actual hardware or software solution that we use to be able to virtualize those different virtual systems on one physical host. And we have type 1 or type 2. Now, type 1 is a bare metal solution or bare metal systems such as ESXi by VMware, where the hypervisor software is installed directly to the physical system, and we run our virtual operating systems through that hypervisor. Now, this only has to go, so for instance, I want to clear up. The virtual operating system in a type 1 environment only has to talk to the hypervisor software that's controlling the hardware to be able to talk to the processor. So there's only 1 degree of separation to Kevin Bacon, or the operating system. Whereas in a type 2 environment, we have the physical host operating system, the hypervisor that goes on top of that, and then the actual virtual operating systems. So we're adding a different layer or another layer to the pie to where the virtual operating system has to go and talk to the actual processor itself. Now, type 2s are generally cheaper, and there are some free solutions out there, such as VirtualBox, which we cover in depth here on the channel. And we're always pumping out content, or trying to where we have VirtualBox solutions for stuff like Kali, POSIX-based systems, and other stuff going on out there. And the reason we prefer VirtualBox is because it's free. Well, and whereas solutions like VMware or VMware Workstation, it costs a little bit of money. And I get it. Yeah, I'm trying to save as much money as I can, but we cover basic virtualization here on the channel. Definitely go check those out. But that's in a type 2 environment. And being in that type 2 environment, we have to be more conscious of our resources that we use for that virtualization. Because whether it's a type 1 or type 2 environment, we have to consider the amount of RAM, the amount of hard drive space, and the number of processors / processing power that we can allocate to each system for virtualization. So let's say, for instance, that we have 2-core processor, I know, and only 8 gigs of RAM and 100 gigs of hard drive space. We can only allocate maximum 2 cores, 8 gigs of RAM, and 100 gigs of hard drive space. And we have to consider in a type 2 environment how much of that is actually being used by the physical host operating system to be able to run that hypervisor. So you can't over allocate resources, otherwise the virtual machine won't run. And that's the advantage of a type 1 virtualization environment, is that you have more allocation of resources to give to those different virtual operating systems than you do in a type 2 environment, because the type 1 environment's dedicated for it, whereas type 2 we have that different layer that we have to add on to that. Again, check out the videos where we go over VirtualBox here. And we also have to consider containers and virtualizations for individual applications. Now, this is inside of the cloud environment itself, where we start allocating more resources. Specifically, I want to pick on hard drive space. And this is usually done through like AWS or Docker, where AWS or Docker will host a virtual environment on a type 1 platform and just allocate different chunks of their virtual environment for us to be able to run an application off of. And that application is utilizing the virtual operating system in that type 1 hypervisor environment. So only thing we have to worry about is the actual application and the resources to be able to host that application. And this would be like a web server. So we're only using the actual web server software to be able to run our website, but we're leaving it to AWS or Docker to be able to run the operating system in the hypervisor environment, be it type 1 or type 2. And this goes into how we store stuff inside of that cloud environment. Is it a block storage or is it an object storage? Well, if we're running inside of our personal environment here, or for our organization, a type 1 environment where we run or even type 2, where we run our own operating systems, we're going to be looking at block storage, because these are large blocks of physical systems to store our actual virtual environment. We have to make sure that we have enough storage containers, physical, like hard drives, and to be able to host all of those different resources. But if we're using something like AWS or Docker, this is where we get into object storage, where we have storage space for individual components. And this could be equated to stuff that we use every day, like the Google Drive. Now, on top of all that, to close this out and start wrapping everything up, is application security. We have to be able to apply security to these virtual resources, just the same as if it was on the actual physical host system itself. So, are we setting security permissions for stuff inside of AWS or Docker, or the actual virtual operating system environment itself? Are we applying security groups like we should be? Do we make sure that certain people have admin rights, certain people don't have admin rights to make changes to those operating systems that are running virtually? What kind of application security do we need to have every user come into our container storage inside of AWS and make changes? Or do we need to limit that ability to only admins or privileged users? We need to make sure that patches are applied too, because in cases of like AWS and Docker, we may be running a individual application and not the whole shebang virtual environment. But it's our responsibility to make sure that everything that we are utilizing or creating is up to snuff on security patches. Because when AWS or Docker, in that case, makes any kind of security changes, they're only updating their stuff, not the actual program that we're utilizing. So we need to make sure that that's taken care of and taken into account. And then encryption. We've already banged on about data at rest and data at motion. We just need to make sure that we're keeping an eye on all the actual resources that users and the actual organization itself is storing and sending back and forth, because we don't want that data to become available to the wrong folks, unless we're pen testing. We'll touch more on that later. Now, here at Panola.edu, we cover a lot of these concepts and go way deeper in the weeds on these individual components. We're just doing a nickel and dime of the objectives here. Definitely check out Panola.edu for cybersecurity, networking, and intro to digital forensics. And as I keep pumping these out, I hope you're liking them. If you have anything, like and subscribe, leave a comment below. Let me know how I can improve or do anything else. And I'll see you in the next one.